Welcome to the ATR final assembly line. We're here in Toulouse, France. So I'm going to show you around the facility, but before we start, I just wanted to say a word on the building here itself, because this is actually one of the oldest buildings of the Toulouse-Blagnac site. And this building has seen the birth of several generations of quite famous and fascinating aircraft. This building was constructed in the late 1930s. It was initially used to produce the high-performance monoplane fighter, the De Watine D520, at the rate of up to 8 per day in early 1940. Later on, this facility was used to manufacture commercial aircraft, including one of the very early transatlantic capable aircraft, the Armagnac, with a pressurized cabin. France's very first passenger jet, the Caravelle, so a beautiful aircraft, very famous design. And later on, it was also used for the production of the military transport aircraft, the Transall, which is still in service in the French and German air forces. And of course, today, we're going to discover production and assembly of the ATR. Let's go. This way, please. ATR has produced one of the most successful ranges of turboprop aircraft. The company was founded in 1981 as a partnership of the French company Aerospatiale, which is now part of Airbus, and the Italian company Air Italia, which is now part of Leonardo. The first original design, the ATR 42-200, first flew in 1984 and was delivered to the launch customer, Air Littoral, the following year. This was followed by a stretch design, the ATR 72, first flew in 1989. Now, over the years, since the original design was launched, new technologies have allowed new series of the ATR and innovations in the cockpits and in the cabin. A new generation of engines has allowed performance to be improved, both in terms of range and payload, and also passenger comfort. The most up-to-date variant of the ATR today is the Dash 600, and on the assembly line today, we will see all the different variants of this series. These include the 42-600, which is the shorter passenger variant. This aircraft will seat between 30 and 50 passengers in the standard 2+2 configuration. ATR is in the process of developing a short takeoff and landing variant of this aircraft that will allow this aircraft to use runways that are as short as only 800 meters long. We will also see the ATR 72-600 variant on the assembly line also. So this is the stretched aircraft. It has a maximum passenger configuration of 78 seats and a range of up to 1,500 kilometers. The most recent addition to the range is the freighter variant of the ATR 72 that has a maximum payload capacity of 9 tons, and this is the world's first dedicated regional freighter. The advantage of a turboprop is that for shorter regional flights, the turboprop is much more fuel efficient and much more sustainable. About half of passenger flights in the world are on routes of less than 500 nautical miles. And so these routes can be operated in a much more efficient manner thanks to a turboprop. ATR is also available as a maritime patrol aircraft. It can be configured also for anti-submarine warfare, and some ATR have also been used for meteorological research. So this represents a total of about 27 aircraft in the world. Finally, there are also 15 freight operators of ATR. ATR aircraft are produced, as I said, as a partnership. The various subsections that make up the aircraft come from different sites in France, in Italy, and other countries for some of the major suppliers. The wings of ATR aircraft are assembled in the Bordeaux plant in Mérignac. Fuselage sections come from Naples in Italy, and the tail assembly, the empennages, come from Foggia. All these parts are shipped to Toulouse as fully equipped, fully tested sections. Yeah, just to explain exactly what we do here on a final assembly line, because the final assembly line is a lean assembly line. So that is to say that a maximum amount of work has been done upstream, and the subsections arrive here at a very advanced state in the production process. The ATR assembly line is divided into two main lines, as we'll see. So we'll start with line A, which is where the aircraft is assembled and general testing occurs. We should also see that for each of the stations we will visit, there are usually multiple stations with things happening simultaneously on these multiple stations. Then we'll go and visit line B, which is where the aircraft is furbished, depending on whether it's a passenger aircraft or a freighter. Of course, we must also paint the aircraft with the colors of the customer. Finally, the aircraft will make its way to Vendée, which is the flight line where the aircraft is prepared for ground testing and for its first flight, test flights, and then delivery to the customer. So we start with stations 47 here, and as you can see, we have two identical stations side by side. This is the entire fuselage section, and unlike certain other aircraft, the fuselage is produced and shipped to Toulouse as a single section. So it travels from the manufacturing site in Naples to Barcelona, shipped by sea, and then continues on to Toulouse by road. The fuselage gets here equipped already with, as you can see, the landing gear. It's already fitted to the aircraft. Flight controls are also fitted, more on that later. The air conditioning packs are also fitted. So let's go and have a look inside and see what equipment is fitted here on this station. So this is the interior of the fuselage section on station 47 with all of the work that is done here completed. And as you can see, the fuselage is well on the way to being fully equipped with electrical systems and harnesses, some of which are fitted on this station along with the electrical power distribution panels. So the primary flight controls of the ATR, so that is roll, pitch and yaw, are mechanical. And here you can see the cables that actually connect the pilot's controls in the cockpit to the control surfaces on the wings and tail. And so these run along the full length of the aircraft, right down to the tail in the case of the elevator and the rudder. And for the ailerons on the wing, so ATR has a high wing. The wing is actually lowered onto the fuselage itself and attached here in 8 places inside and outside of the fuselage. And this is where the flight controls run out of the pressurized part of the aircraft, the fuselage, into the wing and along to the ailerons at the wingtips. This is here to reinforce this section of the fuselage until the wing is fitted, so these will be removed later on. And if we go right down to the tail section of the aircraft, we can see the rear pressure bulkhead, which closes off the pressurized part of the aircraft. This space will be later on fitted with a lavatory, and there's room for additional luggage there. And here on the left side, at the rear of the aircraft, we have the main passenger door. This is a little bit unusual for an aircraft, but passengers will board ATR at the rear and enter through the rear of the cabin. And as you can see, the ATR has its own integrated staircase, which allows this aircraft to use very small airports with little infrastructure because it has its own stairs for boarding and exit of passengers. This is the wing preparation area, and the wing arrives here from Bordeaux by road. And as you can see, it arrives fully assembled, fully equipped with the control surfaces, the various structures. So an ATR wing is made up of a center wing box section and an outer wing box section. As you can see, we already have the engine pylons installed, as well as this here. Now this is interesting because it's a very simple and effective solution for de-icing the wing of the ATR. So these are the de-icing boots. Compressed air, which is actually bleed air from the turbine, from the engine of the aircraft, can be pumped through these boots to inflate them and to crack and remove any ice that might accumulate on the wing of the aircraft during takeoff or landing. The wing of the ATR is also a very interesting mix of materials. So we have both aluminium in the case of the center wing box, and in the case of the ATR 72, carbon composites for the outer wing box. The de-icing boots are made of Kevlar, and the engine pylon is made of titanium for additional strength. So this gives us a very light and strong structure for the wing. And like all large aircraft, the wing is also the main fuel tank, and the fuel is just situated in two main tanks on each side of the center wing box, for a total of 4.5 tons of fuel for the ATR 42 and 5 tons of fuel for the ATR 72. The tailplane of the ATR is manufactured in Foggia and arrives on the assembly line in 3 separate elements. So we have the vertical stabilizer, the rudder that will be fitted to the vertical stabilizer, and then we have the horizontal stabilizer with the aircraft's elevator already installed. So this will be assembled and lifted into position on the aircraft using a gantry. So the original ATR had a propeller with 4 straight blades. The Dash 600 series has a new propeller with 6 blades with a swept profile. It's much more efficient, it allows for better performance. The propeller is manufactured in Figeac, France, by Hamilton. It's about 4 meters in diameter and has a weight of approximately 160 kilograms. This is station 45. This is one of the key stations of this assembly line, because this is the only station equipped for joining the wing to the fuselage. So the wing is lifted into position thanks to the gantries suspended from the roof structure of the plant. Lowered and positioned, the wing is held by 4 cradles, and then the wing is manually joined to the single fuselage section of the ATR using 8 bolts and 4 connecting rods. So earlier on we saw the 3 elements that make up the empennage of the ATR, and on this station these 3 elements are assembled and tested and then lifted into position on the aircraft, again using the overhead cranes or gantries here in the plant. Once this is finished, the tail cone of the aircraft can also be fitted. Additional activity on this station includes a lot of electrical testing, testing of hydraulics, and of the flight controls of the aircraft. Yeah, so the horizontal stabilizer of the ATR is also equipped with de-icing boots. However, the rudder horn has an electrical de-icing system. In here, we can see the connection between the flight controls between the fuselage and the tailplane itself. So the engine pylon is also fitted on this station, and all of the electrical and hydraulic connections are made. The engine nacelle itself, well, the panels are fitted and adjusted here, but the panels will only be closed once the engine itself is mounted on the aircraft. So this is station 25, where the assembly process is finalized. And one of the major operations that is carried out here is installation of the power plant itself. Now, ATR are turboprop aircraft, so we have the Pratt & Whitney 127M turboprop. The 2 engines of the aircraft are of basically the same design. It is a turbine, but unlike on a jet, where the turbine provides thrust via a fan. In the case of a turboprop, the turbine actually spins up the propellers we saw earlier. Most large aircraft, in addition to the main power plant, have an APU, or auxiliary power unit, which is used to provide power to the cabin and the aircraft systems when the aircraft is on the ground and the main engines are shut down. In most cases, the ATR does not have an APU, but the right-hand engine can be used to provide power to the aircraft. So this is called hotel mode. And in hotel mode, there is a propeller brake that stops the propeller spinning and simply allows the turbine to generate electrical power for the aircraft to power its air conditioning and the cargo door, for example. The Pratt & Whitney turboprop is delivered from Canada. When the unit arrives on the assembly line, it weighs about 450 kilograms. About 100 kilos of additional equipment is installed on the engine before it's fitted to the aircraft. This equipment includes the alternator, the fuel pumps, the propeller brake, and the bleed air unit. And so now that the wing has been joined to the fuselage, the Kármán fairings can be added around the wing root to close off this area. So here we are still on station 25, and as you can see by this stage, the power distribution panels of the aircraft have been fitted. And inside the cockpit, we already have the LCD screens and flight controls. And on this station, we will finish the furbishing of the cockpit itself. The ATR's electrical systems are tested thanks to a computer-assisted testing system. And in total, there are over 20,000 electrical circuits in the aircraft that have to be tested individually thanks to this equipment. This is line B, and in this area of the plant we have multiple flexible stations that are used for all of the cabin customization of the ATR range, as well as any final testing that needs to be accomplished on the avionics or the electrical systems of the aircraft. So this aircraft is the newest addition to the ATR range. It's the ATR 72-600F, F for freighter. So this aircraft has the same maximum takeoff weight as an ATR 72 passenger variant, but it does have a capacity of up to 9 tons of freight, and the reinforced floor allows us to carry nearly up to 500 kilograms of freight per square meter. Here on line B, we also fit all the furbishing for the passenger variants of the ATR. This is an ATR 72, and it features the redesign called Armonia for the cabin. Armonia was created by the Italian designer Giugiaro. He's quite famous for designing motor vehicles, cars, anything from the original Golf to the DeLorean, and he's also designed camera bodies for Canon. This redesign allowed greater passenger comfort. If you look at the seats have been redesigned to give slightly more legroom to the passenger. The seats have also been made lighter, so this has actually taken out a weight of the aircraft equivalent to about 2 passengers. And the size of the luggage bins has also been increased. These luggage bins will now contain 2 standard roll-on suitcases. So that's an increase of volume of about 10% compared to the original design. The Armonia cabin also features LED lighting. This gives us a more pleasant environment inside the cabin. It's also more power efficient and lighter. An interesting feature of the ATR is the pilot communications hatch. Because the ATR cockpit side windows are fixed, they don't open, we have this small hatch that is also known as the letterbox that allows messages and paperwork to be passed from people on the ground to the pilot. Once the aircraft is assembled and furbished, and all of the testing that can be safely performed indoors on the assembly line has been finished, the aircraft is brought here to the flight line and delivery center. Some of the tests we have to perform on the aircraft have to be done out here in the open air for safety reasons. Real jet fuel is used to test the fuel tanks and the fuel systems of the aircraft. We also have to test the aircraft's pressurization systems. And then the aircraft will typically perform 2 to 3 test flights before being presented to the customer. Thank you for watching this factory tour, and we hope to see you here in Toulouse soon.